Alrighty. There we go. Looks like we got one of two of two. Excellent. Fantastic. Now I want to just try something. Testing. Chat on Restream. Excellent. Okay. All right. Folks, we are back. And this time we are... Hopefully that didn't show any bad stuff. I don't think it did. I have to keep these guys open-ish. We are live. Double live, yes. Yes, T, as it's all your fault, and you know it is. Because how could you... Yeah, buddy. Excellent. So as the precursor to this, Taylor and I were just having our, it's this, let's go to the slide deck. Oh, yeah, I want to talk about this at some point. Ooh. I love both of these topics. Meta reasoning about code semantics. This is where we're headed, folks. And intermediate representations are the vehicle to get there. That's my strong conviction. Anyway, that aside, the guidance of life is, what is this? Well, there's this, small footsteps every day. And then, what's this? There's this learning thing. Never stop learning. Here we go. Never stop growing learning. So right before this stream, Taylor and I were talking about the challenges of streaming and how we wanted to be on Twitch, but we also wanted to be on YouTube for various reasons. And it's somewhat amusing because our Twitch presence is essentially non-existent. But I'm a gamer at heart. And whether the gamers are paying attention or not doesn't really matter to me. I feel like, yes, we have. We absolutely have. So Taylor dropped the bomb on me, basically saying that there's a way to stream simultaneously and just use this thing called Restream. And he was like, now I know that you don't want to add potentially more complexity to your life, given all the things that we were talking about with the complexity that's going on. And then we hung up and I spent the next, actually, it wasn't really that bad. Like I mostly was figuring out some other things, but then getting connected with Restream was pretty straightforward. So yeah, here we are. We'll see how this goes. Yeah, I mean, I was pleasantly surprised. There were a couple minor hiccups, but it was nothing. There are a couple like early kind of nervousnesses, is that I tried to test the chat and Twitch was succeeding, but YouTube wasn't. So anyway, here we are. We are ready to go. So tonight, it's our Friday night fiasco for us Jeters, and 8:15 p.m. Pacific time. And we have spoken a little bit about versioning. I actually want to talk a little bit more on this. And then I want to talk a little bit about this thing. And then maybe I want to talk about, because I kind of want to talk about abstract classes and pure interfaces and how I think they're actually pretty cool, especially as you're creating contracts and, yeah, well-designed contracts potentially from like a purist perspective, sort of like maybe the functional programming folks tend to think about things. And then I better turn this guy off and turn this guy off. But then I want to go back and I want to talk about this game just a little bit more, because I started watching the stream we did last night or a couple days ago or whatever it was, and I was talking about Caves of Qud to all of you, specifically Taylor, and I wanted to share some of the wacky things that you can do in this game without necessarily, I'm trying not to spoil it, but maybe what we'll, yeah, I don't know. I'm thinking maybe I'll visit their homepage and look at some of the skills. But I mentioned one of the things like the possession that you can do. And I want to share a little bit more about how wacky the possession, just the possession skill gets. And then some of these other ones, there's stuff in here for Myrrh, there's like a time dilation skill where, just as a teaser, so you guys know about the possession from the last video, the time dilation is you have this skill, and I think that you have to trigger it. So it's not, I believe the way it's designed, it's not always active. I think that's the precursor for it. And you have to sort of essentially know that you're getting into danger. Whereas other games, I think like Prince of Persia, it's like always active and then it rolls you back some amount of time. So anyway, this time dilation thing is you have to kind of know that you're getting into danger, and then you can run forward in time some amount of seconds. And then in that period of time, you can jump back. So I think maybe I got it to like 30 seconds, maybe 60 seconds. And then you would use it before like super challenging battles, or like you would see the super bad guys come in. And I thought that was really cool because you literally can just get completely smoked and then roll it back. I think you can just like reverse to a certain amount of time. Like, no, go 17 seconds back. The trick is, I think you could only do it once, I think. And so then there was like a cooldown period. So you had to be somewhat careful about how you abused this thing. So there's two example of the skills that I recall on Caves of Qud. There's the possession one, which is the key to just totally unlocking the super powers of the game in my mind. Because once you can possess things, you can start to possess shopkeepers and like drop everything and then move away. Because I think like, I don't know if you needed to move away, but I did it because maybe it's the like Oblivion days and like Morrowind days where you kind of you could steal stuff, but then if you tried to sell it back to them, they'd be like, that's my thing. Yeah. So with Caves of Qud, I'm not sure if they saw you, they'd bust you. So I would just move them out of the area, and then I'd switch back and then I'd grab all this stuff. But then you can actually sell the stuff back to them. And gold, or their currency, is one of the major limiting factors in the game. Like once you can start to get a decent amount of gold as a form of resource, or whatever their currency is, you can start to really level up. And so the possession skill is one of the first. Now, in order to use it on shopkeepers, you have to be pretty leveled up, as I recall. Again, I didn't play it 441 hours, but I did put in, let's say, like 100 hours of playing this. So I did some experimenting. I remember, I think you need to get possession high enough to where you could do the shopkeepers that had some really powerful things. And then you could start to get like pretty wacky. Yeah. Okay, cool. So we'll talk about this maybe at the end. But before we get into that, I think you could just possess living things. I think that's... Yeah, I think that's right. But it was really cool in that it like you really one I think you would really see the world from their perspective. So if they had certain things that you didn't have, you'd get to kind of see a different worldview, and different people are allies and different people are threats, that kind of thing. You also, for like the shopkeepers, you could see all of your inventory, right? So that was super helpful. And then, yeah, you could even see like their stats. Uh, so you could do some really interesting things. Like you could try to possess the most powerful creature and then have that creature wipe out all the other creatures. And by the way, I think as you're doing this, one of the key things was your old body is like in this complete stasis mode where you're like totally vulnerable. So at any point, if someone is kind of like picking up that you're doing this, they can go be rocking you, and you like don't even, I think you don't even have any clue that it's going on. So you have to kind of like keep track of yourself and be like, am I still alive over there? Okay, cool, keep going. And then I think two, one, it was turn based, so you only have a number of turns before the possession runs out. So it was essentially time walled. And then also, if the person or the creature that you were possessing, if they died, I don't think you died. I think if they died, you just jump back to your original body. Thus, the drinking lava is, I think I had to stick around for that event. And then, and this, yeah, I think that this was one of the like Uber hacks. I'm going down a little bit of a rabbit hole here, but I think it was a little bit of one of the super hacks in that I figured out how to clone myself. So I could clone, like, I think that the bad guys maybe could figure out how to clone me too, but I think I figured out how to clone myself. I think it's been a while. And it would clone not just me, but like all my awesome gear. But then the clone version of me like wouldn't just willingly give stuff up and stuff. So I think I had to kill myself. So, but I was so tough. It's not easy to take me out. But lava was an effective way to do it. So yeah, there's some method to the madness here. We'll get into this. Let's see. Yeah, like, oh yeah, and yeah, maybe this was the time dilation thing. Is like the way that it worked is it would go forward, and then you would see that this was happening, and then decide like, yeah, let's not do that. I can't remember. And yeah, reading books I think it was super useful because it would give you hints on how to do wacky things. Yeah, there are some ingredients in here that were hyper dangerous that you had to be really careful about, like how to use it properly. So anyway, interesting and strange stuff. Yeah. Okay, we'll come back. All right, so starting out, I want to take us a little bit down these less fun topics. We got to do like at least a little bit of learning here. And then we'll talk about this and mostly look at code. And then Caves of Qud. Music stuff has not changed much, although Murr had an interesting song that he added. I think he added the YouTube link to the last video. So feel free to pick that up. It's, I think, his theme song for the dog Merle, and it's super 70s disco kind of thing. It's actually quite amusing. We'll, yeah, look to integrate that. And as far as really bad things that I shouldn't be encouraging you to do, it's not really that bad. But in addition to my Coke Zero, if you have not tried this, by the way, I don't do the whole promotion thing, so this is truthfully on me. These guys, this A&W Zero Sugar, holy cow. I've had people that basically tell me, I cannot stand this whole root beer thing. I'm not interested at all. And they have one of these and they're just like completely hooked. So if you want to get hooked on something that's probably not super good for you, strongly recommend this guy. The way I see it is you could be doing things that are far worse than drinking zero sugar, non-caffeinated soda. So maybe I'm secretly making the world a slightly better place. All right. Let's dig in. The first piece I wanted to share about versioning was to add a little bit more on this, when to use this. And we had this site over here that's giving us some guidance on API versioning and practices, all this good stuff. This is all great. But Untranslatable Metaphor was raising that he had never really heard of this, and so was interested just as something that's like new. And I get that. That makes sense. This is not like a common thing for developers to be doing. The case where I've done it, which I think has been somewhat useful, is for files. So we'll say file type versioning. So you can think of things like doc files, let's say XML files, JSON, etc. And you may be saying to yourself, well, those have these specific structures and layouts, and so why would I need versioning on this? Well, the reason why is this is which version of the XML, JSON, etc. File. The key one is, I clearly cannot type tonight, Nodeka player files. This was actually one of the biggest ones that I did versioning on. And as you might imagine, there was maybe like this read method. And if I'm reading in version 1 versus reading in version 2, knowing this a priori is super important. And the truth is that this was a massive difference, because the first one was essentially this text file. The next was this XML file. And then the next was an XML file. And then the next was an XML file, and so on and so forth. So having versioning inside of the XML file is helpful as you add potentially new types of nodes, or you're deprecating old types of nodes. And the way that it worked in Nodeka is once we got to this format, there would be old data to new data, and so on and so forth. So if I know that this is, let's say, XML v2, and I'm on this v5, the conversion process and the old data could be very different. So let's extend this a little bit more and say that this is v3, old data to new data. And so you probably get a sense that how this is going to unfold. The translation, so it's like the type of old data, and then the like the translation parameters for new data could change from system to system. And so if you build in the versioning for things like file types, this can be quite helpful. So then you have basically your XML file or JSON, but let's just say, so you have this and it's telling you version 3. And then that's like your first node, or you find this wherever it is in the player file or in the data file. And then you can send this information over to the file parser or whatever, the thing that actually does the processing of the data, and process file, and then it takes in like the version. I mean, there's a gazillion different ways to do this. And then this can be variadic parameter data, potentially. I think that the way I did it is it's this, and it's like this thing. Yeah, because I think it was just this tree, because XML systems can be thought essentially as trees. And I think JSON files can be thought of as trees as well. And so I would just send over the tree, and then the version would inform the system on the information that's going to be present or not present. And then the tree will have all the data. And then from that, it'll know specifically like the type information that should exist, and then the translation path that it should have. Now, in this particular case, I think I didn't use a variadic list. And I think mostly it's because I just didn't need it because of this tree thing. But I still would parse out the version, because in my mind, at least, it seemed as though the version information was the precursor for all the subsequent actions. That it's like the one piece of information. This is why I was saying, and I'll say it again, that the first parameter is like the version. It's sort of like the prominent piece of information that's going to dictate essentially all the other actions that you are likely to take. This is only one example of how you would use this versioning stuff in real life, but I wanted to share this given that untranslatable metaphor was saying that he or she had not heard of this or had not considered how it could be used. And so this is like one of the ways. Another way that this could be used, and not necessarily so much in, I think, C or C++, is that you could use it for runtime determinations of things. And the reason why I say not so much for C and C++ is, in my head, I imagine it could be used for things like dynamic type exploration. And there's certain runtime environments that are more amicable to those types of things. I think that C#, for example, is designed to be more fluid for the things like reflection. So it can sort of do certain types of type discovery, API discovery at runtime. And I do think that as we move toward more AI systems, the idea of learning about things in their dynamic execution is likely to become more prominent, especially when you consider things like continuous learning. There's another name for this that the community likes better. I like the name continuous learning. I think it's like active learning, something like this. Is it active learning? Maybe. Oh, yeah. Uh, no, this is not it. This is something else. But I think that they didn't like my continuous learning. Okay, maybe they did. Maybe it's continual learning. I don't know. I feel like there's another name that people have been using more commonly than the iterative learning. Uh, yeah, but it's really the idea of doing this online. I think that's kind of like the key thing is you have sort of deployed the model and now you are going to iteratively learn and improve the model at runtime. And I think that is one of the key futures of AI. And in fact, if you go to Mentor, you'll see that essentially, as I think we saw before, that any whoa. Okay. All right, hold on. What are we looking at here? Selenium? Cilium. Cilium. All right. I think okay, so no disrespecting repos. Writing open source software is very hard. Software in general is very hard. But the reason why I woed is this whole space here looks like a lot of copy paste. I see that the numbers are changing for Mentor. So this gives me an indication that things are slightly changing. Oh yeah. Okay, cool. Yeah. So, this is super interesting. Okay. I'm going to deviate a little bit, mostly because Mentor is observing something super fascinating, and it's a little specific semantic difference and how the semantic reasoner can tell you insightful things in Mentor that a regular expression system can't. So these lines from 28 colon 0 to 29 colon 0 may have the appearance of looking similar from a very quick skim, and that's what they looked like to me. Sorry, I have this. The dog is blocking. Dog, can you come over here? Dog, over here, buddy. Come on, doggy. Merle. Come on. You can do it. Oh, he's thinking about it. He's an old man. Come on, buddy. Okay, he moved. Oh, thank goodness. Okay. Yeah, I've got this back pillow and... All right, back to our point. Now, these may look like they are the same. But you'll notice that, so what Mentor does is if it thinks that they are essentially semantically equivalent, it's going to group them together with the same first number. That's the unique identifier, the UID. And I don't think this is a UUID. So UUID is a universal unique identifier. This is just a unique identifier. And the reason why that's important is this is not a universal unique identifier that transcends across all repositories. Other repositories will have likely their own 28 colon 0, and it's going to look different than this. Maybe at some point in the future we'll change that. That's going to be another one of that catastrophic versioning type of conundrum, but that's the way I think it works today. Okay, so that's the background. And you can see that Mentor is grouping these 28s all the same, but then 29 changes. All right, I think I immediately know why 2029 changes. Yeah. But I want to give everybody a second, especially now that we're streaming this and it appears like there's at least two people, they might be clones of each other, that are on, to see if we can guess on what is causing Mentor to say, no, these are not actually semantically equivalent. So I'm going to give everybody time from now until I finish my sip of my Coke Zero to see if you can guess why Mentor essentially is flagging this one as being semantically different than these other three. Even though they're calling into the same function, CTX store bytes. And I do think that Mentor is probably right, that I think that they are semantically different. Okay. Taylor, no guesses? It might be the feed is so far behind that different files. No, not different files. Good guess. That would not cause it. So in the sense of code semantics, do you see anything in here that looks like semantically kind of different between these guys and this guy? This is a great opportunity for me to drink more soda. I mean, they're doing a pretty good job not having too much copy paste. That's like 2 is not super bad, but this one here, like, whoa, that is a lot. But admittedly, you do see these different numbers, which tells you they're doing something potentially semantically slightly different. Okay, so the semantic difference that I'm seeing is, and I'm not totally sure, but I think that this is what Mentor's zooming in on, is when you have a function call, this is essentially a value that is being calculated dynamically. So the semantics of this and this and this, S address, S, trying to see what, I do see some differences of S adder and D adder, but squinting, trying to find S. I'm not sure I see those. Maybe I'm on the wrong. Oh, wrong line. Okay. So, oh, I see. S adder. I see. You're like looking maybe. That is probably why these are potentially different. It's not the struct difference per se. So it's not that this is taking the address of tpnew.sadder, but instead it's the fact that this second parameter, or sorry, second from last parameter, is size of IPv6 dadder, and this is a fixed constant. Because the fixed constant, the semantics of this are, it's static. It's the number 8 every time. Whereas this is dynamic. And therefore, the fundamental semantics of that parameter are different. And Mentor is zooming in on that, saying, no, these aren't exactly the same from a semantic analysis standpoint. And that part, I think, is actually kind of cool when you're starting to reason about why it might break these down differently, is that these guys essentially are all figuring out the last parameter based on this size of. So they're all dynamic construction. And so when they fail, if they fail, they're likely going to fail all in the same kind of way. In particular, they're going to fail when this size of value is somehow outside of the constraints of the system, which is going to be dynamic. This one, on the other hand, its last parameter is this BPF recompute CSUM. This is fixed value. This is static. And so this will fail in very different ways or succeed in very different ways. In essence, if this executes and succeeds, then it's likely going to succeed every time. Now, admittedly, this parameter here, size of HL, is different, and it's different than these guys, but you did have some of that in this these other cases. Not the size of, but you have some other sort of dynamic values looking like these are coming from variables. This is slightly more complicated in the sense that this is a function call that's going to do something, but similar idea. So at a high level, what I think that Mentor is doing here is essentially saying that even though these are all similar-ish, which is why Mentor's scoring them in a way that's going to group them almost all together. Notice that these other guys, they don't sit between them, so they're kind of getting approximately the same score, but they're not identical because these numbers change. So it's saying like these three, 28-0, 28-1, 28-2, it's saying these guys are identical semantically. And I think Mentor's probably right-ish on that. And then another one is saying these four, 32-0 to 32-3, are also identical semantically. And this one right here, this is actually, I think, really interesting, is saying 32-3 and 32-2 are identical, even though the value itself changes on the second to last parameter. And that's because from a semantic standpoint, that's just a numeric change. It's just, in one case, it's the value 2. Another case, it's value 8. In another case, it's the value 4. Semantically, though, it's still just a fixed constant. It's not a function call. It's not something that's going to dynamically change. And so the semantics of this, in some sense, the behavior of this succeeding, failing, doing something is going to be similar-ish. This is a bit hand-wavy. And the reason why this is a bit hand-wavy is the formal definitions of code semantics are still being figured out right now, at least from a perspective of machine programming. We've had other semantic analysis systems that we've seen in the past, like operational semantics, denotational semantics, axiomatic semantics. And all of those things are super cool in various ways, either for things like theoretical computer science, when you're trying to understand properties of systems, as far down as how to reason about data dependencies that you have for compiler optimizations, where compilers can reorder things and do cool out-of-order execution. But the semantics that we're going to start reasoning about with advanced AI systems, I think they're going to start to reason at algorithmic levels, not just at instruction levels. So operational semantics, small step operational semantics. I think that's actually a thing, right? Small step operation. Yeah. So things that look like this. Again, this syntax may look a little confusing and complicated and scary at first, but it's not that bad. It's sort of just indicating that there's like, and again, I'm not an expert in this, so it's been a while, but it's sort of like you're going to start with this state and it's going to transition into this state. And then when that happens, you'll have something that can do also transitions. So these are like these state transitions. This is like super useful for reasoning about state changes that exist in programs when you're trying to reason about simple small step operations. And I say simple, I don't mean that as like this is simple. I mean, as in we're trying to reduce the complexity of what is happening in the program to the most sort of simple elements. So then we can see exactly what the transitions might be in the program state, the program behavior, as you perform one of these state transitions. You can go from one state transition to the next in, again, arguably the simplest way possible. So, and then you also have, like the big step stuff, but there's much more work that we need to do in order to apply this type of stuff. Yeah, this is what we were just talking about, is the axiomatic, denotational, and this is operational. I think this is operational. Yeah. So really useful stuff, but there's more. I believe there's more semantic reasoning that we need to invent, which is some of what we've done at Merli with what you're actually seeing here. This is one of our new semantic systems, like that's figuring this out. This is not. I'm trying to think if you can do this with the existing semantics systems. Maybe you could, but this is sort of a more natural way, I think, to do it for the Merli system. And if you're curious about the way that I think things are going to go, I think that things are going to likely head directionally toward some of this wackiness. And I feel like there was a picture that we had. Well, this gives you some sense of how I'm thinking about semantic reasoners. This is a semantic hierarchy, and the lowest level is dealing almost with essentially the syntax. So the bottom level, I think, for PSG, like level 0, that is at the syntax level, it does actually just think about syntax. But then as it moves up the chain to higher order levels, it moves into concepts. And then as it gets to the top level, this is just an example of a program. This isn't all the things that can exist in the PSG. But what happens is when you get to the very top, you essentially have two fundamental categories. You have the data and control. And I feel like the parallel here is there was discussion about how all programs can be broken down into two things, data types and algorithms. This is like one of the formal definitions of programs in computer science or something. All programs can be broken down into the data types they exist and then the algorithms that they use. And so there's a very similar like ontology that's emerging here, is that these are things related to data. And this is related to control, which is essentially like the algorithms. Now, I don't know necessarily that we got all this right, and I'm fairly certain that we didn't. Keep in mind, too, what's really interesting about PSG, the program-derived semantics graph, is while we presented this at a NeurIPS workshop, and people, I think, were somewhat excited about kind of the craziness that you could do with this, we never figured out a way to automatically build the PSG. We only could figure out how to construct the vocabulary and the space of what the PSG would look like. We weren't able to figure out how to build a system that could then take code and then construct these graphs. We don't know how to do that. These are hand constructed. And the reason why we couldn't do this is that we don't have a strong enough understanding of code semantics, in my mind, to be able to build this type of thing. That intuitively, what I think is like the idioms we are capturing in the PSG, I think are super valuable and I think semantically correct-ish. And even if you don't believe me, I think that some of my co-authors, I think at least one of these two ladies are like ACM fellows, so they're like pretty prominent figures. And they're profs in computer science at UCLA. Like they definitely know their stuff. And all of us couldn't figure out how to build this. So this isn't like just Goju is not smart enough to figure this out. I mean, there's lots of stuff that Goju is not smart enough to figure out. But the four of us working on this, and Roshni Iyer was one of our PhD students who's a rock star, and she was working around the clock, and she couldn't figure out how to do it. This is a hard problem. This paper, I think, in some sense is... I think the way I teach this at the university, because I think this is in one of my lectures, in fact, oh yeah, oh yeah, I actually talk about the PSG in this lecture. Yeah, because it just dawned on me that this is the closest to starting to do meta reasoning. This doesn't do meta reasoning, I don't think, but it's the closest. And in this, what do I say? I say something that I think this... I think this may be... I thought I said it in the slides. If not, then I definitely say it during the class. Oh, yeah. Here, yeah, I do say it in the... And maybe this is part of the review feedback, or maybe this is part of us. Why the program-derived semantic graphs? PSG may be in a class of emerging structural representations that cannot be built from a traditional set of predefined rules and instead must be learned. Okay, think about this for a second. Imagine if you have an intermediate representation, like the IRs that we have that exist today. So all the different intermediate representations, LLVM, MLIR, abstract syntax trees, program-derived semantics graph, CAS, simplified parse tree. Here's some of the fun ones, right, that we talk about in this lecture. All of those are built, to my knowledge today, based on rules that exist that explain how to build those IRs. And principally, the reason why those rules exist is you're going to follow those rules, and then you're going to get the resulting thing that you're trying to build. So the abstract syntax tree in this case, or the simplified parse tree in this case, you're just going to follow those rules. Now imagine that you had a new IR type that is super powerful, but turns out there are no rules that are going to get you there, and instead they have to be learned. Very much like how we're using machine learning to do object identification in images or video. Like, oh, that's a dog. Why do we do that? Well, it's very ambiguous. It's super nuanced. And it's hard for us to come up with the precise rules to say, oh, that's a dog. It's like not super clear. Otherwise, we would have just used rules for it. And there's a lot of things in the world that are also of that similar space. And so one of the ideas in this, and again, this is like we're on the bleeding edge of science here. To my knowledge, this does not exist yet. Maybe it does, but when we wrote the PSG paper in 2020, or that's maybe when we presented it at NeurIPS, I don't think this existed. So I think it's possible that some of the future IRs, like PSG, will be these abstractions that capture notions that are really powerful that we have a very hard time articulating as precise rules. Maybe those rules can exist at some point, but we don't know how to define them yet. And so instead, we're going to use an AI system that's somehow going to learn how to do this, and then the AI system will do the transformation for us. Maybe then we'll reverse engineer the AI to then lift out the rules. But again, if you're scared that the AI is going to be stochastic and then give you different trees or graphs or whatever IR, just know that you can build deterministic AI systems so it gives you the same IR graph or tree or whatever every time. And an example of that, again, is the way that Mentor works. So I wouldn't panic too much about this notion being stochastic. There's ways to do it deterministic. And that's going to be, I think, super useful here, because the first time we learn this, we're going to get this wrong. Probably the first 1,000 times we learn this, we're going to get it wrong. And we need a deterministic system that we can iterate on, do iterative refinement to make it better and better and better until it's finally building the right PSG. And then once we have that, we're going to be good. And when you can start building this kind of craziness, then you can start to do some really wacky, powerful things like full algorithmic rewriting. You can literally do this type of thing where someone implements exponentiation in recursion, and then this PSG thing can say, semantically, I think that these things are the same. And so here's the iteration version of this, and here's the power version of this. And I see that there is a 70%, 80% overlap. So they're nearly the same. I can rewrite this in an iterative form. Why would you want the iterative form over the recursive form? Many reasons. Iteration is not going to blow the call stack. If you want to have this work on an embedded system, this is likely going to be better for you. On top of that, iteration tends to perform more effectively. Why then would you write the recursive form and not the iterative form? Iterative form of some of these systems tends to be, as strange as this sounds, can often be mentally more challenging for humans when you start to really understand certain powers of recursion. And maybe the recursive form of exponentiation is not a good example, but I suspect if we thought about this, we could figure that out. Fibonacci. is like so easy to do with recursion. It's literally just like, what are the last two things? Okay, cool. The next version is call the function, and then that just with this thing, and then the one prior, and then that's the answer. And then you just keep recursing out until infinity or something like that. What does the iterative version look like? You got to keep track of things like, okay, this is the second to last, move that forward. So there's like more bookkeeping, for example. So anyway, hopefully now that we've gone down a little bit on this rabbit hole on semantics and why a hierarchy of variable granularity of semantics can be super important to track for machine programming as we start to do really powerful things like transpilation, full program transpilation from one language to the next. Like, this is the kind of stuff that I think we need to get there if we want to do this in like a real way, in a way that's more actual engineering and it's more robust than like hand wavy. So with that in mind, part of the stuff that we're interested in early is semantic reasoning. And so we build stuff in. So while we don't have the ability yet to necessarily learn how to build a PSG, we are to the point to where we can detect things like this and say, while these are similar in value, there is not a perfect semantic equivalent because these are different types of operations. You could think about this as something like small step operational semantics, in that it's looking and say, this is a function call, this is a constant. Those two things are not semantically equivalent. Small step. Cool. Okay. I think we were looking at this for a reason, and I have no idea what that reason was. But I feel like we've dug in deep enough that I don't know that we need to go any further. So maybe we won't. Maybe we'll just stop right there. Let's revisit what we were talking about. Yeah. I think that we've meandered quite a bit, starting to talk from versioning of files. I think hopefully Untranslatable Metaphor will be happy that we talked a little bit about this. And sweet. Yeah, I was probably talking a little bit fast there. I wasn't trying to do that to flex. Just to be clear, I just have spent some time thinking about this. As I suspect some of you can probably tell from, I mean, if I have like a full lecture talking about, like, literally the purpose of this lecture is to talk about how you could start to breach the topic of meta reasoning for code semantics and why intermediate representations play a fundamentally important role in that. And this is my strong conviction. And by the way, I think we all know I don't really ever try to sound fancy. So when I say things like, I think that's probably small step operational semantics, I mean that's probably small step operational semantics. And those aren't just random words thrown together. It's like, no, that's like a thing. And so similarly, I'm not trying to sound fancy here. This is actually how I think we would do this. So let's break this down real quick, just so we understand what these words mean. So when we think about code, at a very high level, we can think about code maybe in two ways. It's syntax and it's semantics. The syntax is like, what does it actually say? So the syntax of this is Justin Gotchlick. That's the precise syntax. What's the semantics? The semantics is like, this guy is going to be just the teacher. So the semantics behind this entire phrase is like teacher, professor, something of that nature. It's telling you the meaning behind the actual syntax. So similarly, you can do the same thing with code. Is you can have the syntax say, this is an if then type of syntax, and then the semantics of that would be it's a control expression. So control expression is something that's going to control the flow of the program. So does it say control expression? No, but that's what it means, right? So that's where we start with the code semantics. So we care less about the syntax, like so all the stuff that it actually says, and more about like so what does it actually mean? By the way, this is only step one. The next step is code intention. Code intention is a step above code semantics. So code syntax is what is it saying explicitly. Code semantics is what does it mean. And code intention is what was actually intended by this thing. I think that, and as you'll see in the 3 Pillars paper, I think that intentionality of code is like a more interesting and more complex problem than even code semantics. It's like I had the analogy as I was saying it, but then it kind of slipped my mind. Oh, it's the analogy that I have where I think readability is more important. Code readability is more important than code correctness. This is my strong conviction. And that may sound strange at first. I was like, why would readability be more important than correctness? The reason why I think this is the case is that if code is highly readable, it's very easy to make that code correct. Whereas if code is just correct, one, it's not necessarily readable, and two, as code needs to evolve, you likely need readability over correctness. And so if you start with correctness as the baseline, and you start with readability as the baseline, and then the code is mutated, but it always stays readable, it can iterate much more easily. And I think the key thing about software that is going to be useful is that it can iterate easily. Just because the code's correct doesn't lend itself toward easy iteration. Similarly, code semantics is just telling you the meaning of the code. So like, what does it mean? What it's doing? That's cool. And that can be super useful. But what was actually intended by this? And so what code semantics will do is tell you the meaning of like what it's actually doing right now. Intention will tell you, but here's what was actually intended when the programmer or the AI or whatever was writing this. And then with that, you can evolve the code to more correctly capture the intention by expanded semantics. Because the semantics will essentially just tell you what it means right now, which may or may not match what the intention actually was. Whereas if you can figure out the intention is like, this is what I intended for this thing to do. The semantics are wrong here. Now, how to do intentionality reasoning? That's a doozy. I have some ideas. I'm not sure I'm allowed to talk about them, so I'm not going to talk about them. And I don't even think I teach them. Do I teach them? Maybe. I might hint at them, but I think I've talked to Taylor about them a little bit, but anyway, once we build it and it's doing stuff, then you'll see it in real life. Okay, so there we have it. We have the code syntax, we have the code semantics, and then we have the code intention. All right, so those are like the 3 levels. And likewise, we have a thing called reasoning, and then we have a thing called meta-reasoning. Again, this is not intended to be a fancy word. It means something different than reasoning, and it's super important. Reasoning is essentially to think about stuff in terms of what you have. So you're going to reason about the code semantics. You're going to reason about the code syntax. You're going to like look at that kind of thing. Meta reasoning, like the highest order of this, is it's one layer of indirection away from the original thing. So meta programming, it's not programming, it's programming of programming. So meta reasoning, it's reasoning of reasoning. So why is that helpful? Well, when you reason about stuff, you're reasoning directly about like that thing. When you're reasoning about reasoning, you can start to think about problems that give you insight into things that might not be present in the thing that you're analyzing, but might have artifacts in the reasoner itself. For example, if you're doing reasoning on just code and code semantics, you're probably just looking at the code. But if you're doing meta reasoning for code semantics, you might look at the code, but you might also look at the comments. Why would you look at the comments? The comments are giving you insight about what the person or people are that are writing the code. So is it code? No, it's comments, but it's meta reasoning, and that you're not just reasoning about the code, you're reasoning about what the person that was writing the code was reasoning about. They're telling you, oh, hey, this algorithm is meant to do this thing, and that's why this check exists. So you have the initial reasoning you would do on the code. You're looking at that, and then you're like, oh, now look at the comment and see the programmer's intentions were essentially to do this. Now let's reason about this piece too, and then see if this gives us insight into the code semantics doing what they're supposed to do. Now you can go much further than that. You don't just have to look at the comments. When you're doing meta reasoning, you can look at all kinds of things. You can look at the environment. You can look at the commit history. You can look at changes that happen in the code over time. You aren't constrained necessarily to just like looking at any individual piece of code and saying that we're going to just think about this thing. The meta reasoning is saying like we're going to look at all the different things related to this thing, and including the programmer that wrote it, their team, what time of day they wrote the code, all of these things that are meta. Kind of think of like the reasoning is this bullseye, and the meta is like all the stuff that's around it that could have influenced the decision making that maybe helped them get it right, maybe is the reason why they got it wrong. And then through that reasoning, you can then figure out more things. It adds many dimensions of complexity, but it removes you from too narrow of a view of the universe that may prevent you from solving the problem that you're setting out to solve because you don't have enough information. So like if, for example, if you, hey buddy, awesome. So for example, if you're just looking at this, you might not know if this is actually the result that you want. But if you step back and you look at the larger context of code or comments around it, you can see, oh yeah, this is actually right. And now I can zoom back into this code. So that's kind of like a very simple example of meta reasoning. The one that I think is more interesting, just to give you a concrete example of how I anticipate this will be done and could very well be being done today, is that the meta reasoners will reason about the programmer, whether it's human, AI, combination of the two. And then from that information, it will then draw conclusions about behaviors that it knows about those humans. So for example, if it's a human, and the meta reasoner may figure out details about that human. Like, are they an expert programmer in this language? Oh, they're not? Cool. We can expect that maybe they didn't get it right. Okay, it's an AI that's doing this. Okay, what AI, what version, what kind of issues do we know that AI had at the time? Do you see how valuable this is? Is that now, especially like the AI example, is if we know that it's an AI that wrote this code and we know the limitations or issues that existed with that model generator, now we likely can see the gaps that might exist in the semantics that will tell us where the bugs are, right? And say like, well, the semantics say this, but what their intention actually was this. Maybe I've given away a little bit on how to reason about intention. By the way, this is not the superpower way of doing intention, but a simple example. And then from there, you can do things like automatic potential patching of the code because you understand the actual system. You are reasoning about the reasoner that wrote the code, and then you understand exactly what the semantics are, and you know about this system's limitations, and so you can kind of like see the fix to some degree. I still think these will be probabilistic systems for the most part, unless you have formal verification components, which, as we've discussed in the past, are generally computationally intractable, at least pre-quantum devices. But having it be probabilistic with like 5 nines, 99.999% accurate might be good enough, at least as a starting point. Because then some human can come in and be like, yeah, that looks right. I've looked at it, click. This is pretty good. Okay. I think everybody's head is going to explode at this point because so if I teach an advanced version of this class, if there was like the machine programming 2, 429M or something, or 329N, I guess. Although I think M is reserved. I think the uni reserves M as like machine learning, like core machine learning. So I think the M is fixed. So it'd probably be like 429 or 339M. Yes, isn't it? It is crazy the number of things you could start to reason about once you no longer are restricted to reasoning just about the code. It's mind-boggling, the stuff that you can explore. And that's where I think we need to go in order to do more sophisticated things. But if I did a more advanced version of this class, it would probably be on this. It would be about meta. I think maybe I've mentioned this. I don't know. There's too many things to do, but it would be principally about meta reasoning on code semantics, and it would be about the 2 axes of temporal analysis for machine programming. Those, at least in my heart of hearts today, those would be the 2 that I think I'd try to focus on. Okay, cool. I think that's good for today. I said I was going to end talking about Caves of Qud. So let's talk about this just very briefly. But not too deeply. Okay. I'm trying to figure out how I can share stuff and get you excited without spoiling it. And I'm starting to think that yes. Maybe I shouldn't talk about it. Maybe just me showing you that like I didn't play it this many hours, but you see the games that I'm spending some time on, right? So Baldur's Gate got some time. Elden Ring has some time. How many hours did I spend? Oh, Path of Exile's got some time. I'll admit it. I was playing Stardew Valley at one point, mostly because it's a really fun. Although, yeah, I heard recently they did like a Baldur's Gate version of Stardew Valley. And I guess like Wizards of the Coast was trying to block it or something because of like IP infringement, but I think that's resolved now. Anyway, this is yeah, you should check it out. I mean, I'm probably misremembering, but yeah, so there's like a Baldur's Gate version of this, I believe. I think I'm remembering that correctly. Let's check it out. Baldur's Village. Yeah. The Baldur's Gate 3 mod for Stardew Valley. Yeah, I was thinking about actually bringing it up myself just because Stardew Valley was pretty amusing to begin with, and now there's like the Baldur's Gate version of it. That's probably going to be pretty fun. Anyway, so there's games on here that I think many of us know are some pretty awesome games. I also played this one a little bit. This one's pretty cool. There's that metaphor game. Where is that? I wanted. Oh yeah, I started to play Inscription, and then what I realized is I enjoyed watching Markiplier play Inscription more than I enjoyed playing Inscription, and so I think I'll just watch Markiplier play it. By the way, again, if you don't know who Markiplier is, I strongly recommend you check out his stuff. This guy is arguably one of the best VODers, I think, on the planet. He has so much energy. He has great character acting. He's just hilarious to watch. It's like family friendly. Well, except he plays scary. At least the ones I watch, it's scary games. So maybe it's not for like the 10-year-olds, but maybe if you're okay, maybe it is the adult crowd. Not that he swears or anything or says bad things. He's actually pretty good about not doing that, but there are some scary themes, and he is dying quite a bit from various things that are trying to murder him. But yeah, Inscription is in there. This one, oh, what's up with my hours? This game, I loved this game. Loved this game. I don't know why it's not showing any of this stuff. I think it was indies. Maybe I ended up playing it on my phone. I think they had a port for the phone, and it was just super awesome, so I just played it on the phone. Anyway, so you can see. Sweet. Yeah, I don't know what the Detroit Becoming Human, but I'll check that out. Jack Septic Eye? That's cool. So anyway, going back to Caves of Qud, if I'm looking at this for, again, not this many hours, but probably a fourth of this, this is some wackiness. And just I think, if nothing else, the creativity of the various things that you can do in this game and how wacky it is. Like the possession stuff and the time dilation and various other sort of multi-dimensional tearing type of stuff that you can do. It's pretty cool. I think that you should check this out. Also, the world, I think, is pretty large, and it's also pretty unforgiving, that you can get yourself into just dead over and over just by trying to leave the town. So you have to be really careful about where you go, but you like build these factions, and then by building up trust with different societies, and the societies don't necessarily get along, and so it's got really complicated game mechanics. Kind of like reminded me of Nodeka in the sense that the game mechanics are very complex. Except if you had the freedom to go like fully wacky, you didn't have to support an online community where things need to be kind of controlled. so the players don't become so like god level, like god tier that they're just wiping the floor with everybody else. This game doesn't have those restrictions, and so yeah, you can get to some interesting demigod stuff. You can also very quickly brick your character. That if you're not paying a lot of attention, which is what happened the first time I created my character, like I got some infection or something. I was like, whatever, it's going to be fine. I drank the healing potion. I wasn't paying attention to it. I think that thing eventually killed me. And it was like, as it progressed far enough along, by the time it's like, uh-oh, your foot doesn't work anymore. It's like, well, how can I fix it? Well, you can't. So have fun with the remaining 5 days of your life. And then on day 5, it's like, okay, you're done. And then I was like, am I really done? And I was like, I was pretty sure I was done. And I had to basically start all over. So yeah, again, that was probably just me being stupid, but be careful because it can be very unforgiving. And yeah, if you're not paying attention to the things that your talents, your attributes, yeah. And it was the worst part too is it wasn't just the foot. Is like it started with the foot, and maybe if I amputated my foot, I'd be okay. But then it like crawled up the whole body, and it's like, nope, it's everywhere now, and so you're done. Anyway, super awesome indie game. I strongly recommend you check it out. If nothing else, it's going to be a mind expansion and make us all better people by thinking about some of the wackiness that you can do as an indie developer. Okay. Thanks, everybody. This has been super awesome. This is our first attempt at doing the restream guy. And we're going to find out very shortly if this actually works with uploading these streams and stuff in the various places. Although I suspect I'm probably going to minimally do like audio correction and stuff and then make it 4K for YouTube. Excellent. Well, we will see everybody possibly tomorrow night. And from my side, Merle, come on. Come on. Merle, come on. Come on, buddy. Merle, come on. I want the dog to say, come on. Okay, from me and the doggy. Everybody have a great night. This has got to be the thumbnail. Let's just get it right. Yeah, there we go. This will be our thumbnail for this episode. All right, everybody. We see you tomorrow.